Qualitative versus quantitative in statistics. So qualitative and quantitative are your data types in statistics, also named as following. So qualitative is also known as your categorical data. Basically, it represents categories and labels, while quantitative data is your numerical data. So numbers, countable, measurables, uh, usually using mathematical operators, so addition, subtraction, multiplication, so and so. With qualitative data, also called categorical data, you get two sub-data types, which is nominal and ordinal. So nominal data is no specific ranking to the data. For example, like a eye color or a place or a car name, there's no specific ranking or order that it follows. Example, like a eye being blue or eye being green, it's just the color. There's no care to it, as opposed to ordinal data which follows a natural order. Example, like a client satisfaction level. So if you get a client that's unsatisfied or very unsatisfied, then neutral, then happy or very happy, it follows a specific order of data, which is the natural order that it needs to follow. With your quantitative data types, also called numerical data, this has to do with numbers. So you get two sub-data types, which is your discrete, your whole numbers, example, a number of students or number of siblings that you have. It'll always be a whole number. You can't have 5.5 students in a class. You either have 5 or you either have 6. um, it's full on numbers that you have, like if you naming like cars in traffic, you've got 5 cars currently in traffic. You're not going to have 5.5 or 5.5 or 3.5 cars. It's always going to be a whole number, as opposed to your continuous data, which has no limit in measurements. So if you're counting like in centimeters, or if you're counting the time, you've got 9 o'clock, you've got 10 o'clock. Your time in between is your continuous data, where there's no limit in the measurements. It can go on and on and on, or it can go as far as your measurement instrument takes it. For example, if you had a count in seconds or in seconds, you've got 1 second, you've got 2 seconds, you've got 3 seconds. But in between 1 and 2, you've got like your 1.5, your milliseconds. And then lower than that, you can have your 1.555 or 1.666. Can go on and on. It's basically your decimal figures. So height is known as a continuous, your time, your temperature, you'll have like 39.5 degrees and stuff. So that is your continuous data. Um, this is a table representation of qualitative versus quantitative. So example, you've got nominal, you've got ordinal. So a blood type, a car brand and stuff all fits in your nominal data where there's no natural order to it, as opposed to your ordinal data, which could be a t-shirt size or your shoe size, which follows a specific order. So you have like extra small for your t-shirt size, and extra small, small, medium, large, extra large. It follows a specific order. So quantitative types, you've got your discrete data, which is like number of pets in like your household. You could say I've got 3 pets or I've got 4 pets. You'll never have 3.5 pets. Your daily steps that you take in a day, your daily steps will always be like 20 steps in a day, 50 steps. It'll never be 50.5. Same with your continuous data. So your continuous data is like your weight. Your weight could be 35.5, uh, income. So, okay, then you get data which can become mixed and ambiguous. So by looking at it, you could think it falls between nominal data or ordinal data, when in fact it could be your numerical data. So some variable may seem as numbers, but actually categories. So for example, postal codes. If you had to look at postal codes, like in the example here, we've got 54789 and then 790 and 791. It looks as if it follows a specific order. However, it doesn't, because the postal code doesn't matter. You could have people queued up with different postal codes from different areas and stuff. There's no specific order to the postal codes. Same goes with voting. Example, you could have it if you had to go through a voting poll and if you had to vote for people's names, like for example, 1, vote 1 for Daniel, or vote 2 for Nigel, or vote 3 for Marcus. It's labeled numerically as if it follows a order, for example, 1, 2, 3, 4, but it actually doesn't. It doesn't matter if you vote Marcus first or if you vote Daniel second. It doesn't really matter. It's just the label to the names. This is basically the basics of data types in statistics.